Hello everyone, welcome back to my channel. In this video, we're going to solve this exponential equation. 8x is equal to e to the power of 2x. If you notice, this exponential equation is not normally what you see in the previous ones that we have solved. And so in this case, we're going to use the Lambert W function to find the value of x. So what will be the first step? Normally what we do is separate the variables from the constants, right? So separate the variable on one side, and on the other side we leave just the constant. Alright, so let's start. And so in this case, we're putting the variables on the left hand side of the equation and the constant to the right. So how do we do? So we have here 8x is equal to e to the power of 2x. So by dividing the whole equation by 8 and e to the power of 2x, right? So 8 times e to the power of 2x. So we ended up canceling this and canceling this. And what we have left will be x divided by e to the power of 2x is equal to this cancels, so we have 1 over 8. And so now the variable is on the left side of the equation. So what will be the next step? So if you notice, this is a fraction, so we can put the denominator to the numerator. So we'll end up having this x multiplied by e to the power of negative 2x. Okay, that is from the formula. If we have here 1 over a, and we're putting this a to the numerator, this will become a to the power of negative 1. And it's from here, the exponent of a normally is 1, even though it does not show normally as 1 there. It's understood if there's no exponent, that means the exponent is 1. And you put it on top, there will be a negative exponent from positive to negative. Okay. Then let's go back to our equation. Right hand side remains the same, 1/8. So now we need a formula for the W Lambert function. So let's introduce the format of an equation so we can start using the Lambert W function. Let's say here, if we have x times e to the power of x is equal to some constant. All right, so this is the format that we're going to target, or at least manipulate our equation to this format, so we can use the Lambert W function. For the Lambert W function, we have here introduced w multiplied it to x times e to the power of x. We'll be getting back the value of x. All right. And here the value of x can be in any form, right? What I mean by that is the value of x can be a negative 2x, or x itself, or other constant and another x. All right. So now going back to our equation again, we have here now where our target is x times e to the power of x is to some constants. Right hand side is constant, 1 over 8. And here the variables is like this. And if you notice again, the base x and the exponent is negative 2x. Based on this format, the exponent must appear the same, exactly the same as the base, or the base exactly the same as this exponent showing up right here. So that would be in this form, x e to the power of x is equal to some constant. So then we'll be doing some manipulations to make this left-hand side of the equation with the same base look exactly the same as the exponent over here. All right, so how do we do that? So if we take a close look at those, the base and exponent, what's the difference? It's just negative 2 in the front of x, right? So then this equation can be manipulated by multiplying negative 2, that's to the left and right hand side of the equation. Okay, So let's multiply this by negative 2. Alright, so this is now negative 2x times e to the power of negative 2x equals negative 2 times 1/8. So that is negative 1/4. And so now we have the base the same as the exponent, right? So we are now ready to plug in the Lambert W function, alright? So let's multiply this, or let's integrate Lambert W function to the equation. So this means we're multiplying w the same way on the left and right hand side of the equation. So this is now w, so negative 2x times e to the power of negative 2x equals w sub negative 1/4. And so by having this format, if you take a look at the equation over here, we can get back the value of x, where value of x here is in the form of negative 2x, right? If you notice. So the left hand side is now negative 2x. That's the value of x. Alright, and the right hand side is w sub negative 1/4. Solving for x, what we have to do is divide the whole equation by negative 2, right? So negative 2. So x is equal to negative 1/2 of w sub negative 1/4. So this is one of the values of x, and here, if you notice, this is negative 1/4. This means that there's another value for x. So the second value will be x is equal to negative 1/2 w sub negative 1 times negative 1/4. So these are the two values of x. Since we cannot solve the numerical value of x in this sense, so all we have to do, if you have access to computer, or if you have the cell phone and you have the Wolfram Alpha app, all you can do is plug in this value or this value or both of these. You can get the value of x for this and the other value of x for this. But in this sense, for here, for this value of x, by using the Wolfram Alpha app, all you have to do is enter that's since it's negative, so you have negative 1/2 product log of negative 1/4. That's for this value of x. And for this value, w sub negative 1, plug in negative 1/2 product log parenthesis negative 1 and then negative 1/4 to get the value of x, the numerical value of x. So this value of x is approximately equal to 0.1787, and the other value of x is approximately equal to 1.0766. And if we take a look at the graph of our equation, we will have the y and the x-axis. So you got 10 mark on the y, and this 5, and let's say here 1, and it's 2. The line 8x is, let's say, somewhere here, crossing the origin. So right here should be the line, and this is 1, and this is about the half point, 0.5. The first intersection, that's 0.17, and the intersection is about past 1, somewhere here. So we have the curve e to the power of 2x. We have here intersecting the line at this point and then going up. Alright, so intersecting the line at this point. So this point right here is 0.1787, and this point right here is 1.0766 approximately. So this is the curve e to the power 2x, and this is the line 8x. And so that's the graph of our equation. So now going back and to sum it up, so solving equations like this is kind of complicated because you need manipulation of the terms of the equation to adapt the Lambert W function so we can solve for the value of x. So first, move the variable on one side and constant on the other side, like what we did over here, and then manipulate the variable side. So we'll have the format of this kind: x times e to the power of x is equal to constant. So variable on the left, constant on the right, and then we can integrate the Lambert W function w to the equation. So we'll end up getting back the value of x. So in this form, value of x can be any number or with a variable. Like in here, you got negative 2x, right? So since the base is not equal to its exponent, like in here, x is the base and exponent is 2x, negative 2x. So we have to manipulate the terms of the variable to make it the same base and the same exponent. So by multiplying with negative 2 both sides of the equation, like what we did on here, and then get the value of x as in the form of negative 2x, then solve for the value of x. And solving the numerical value of x is impossible doing this by hand, so we have to resort to computer or our cell phone. If you have the Wolfram Alpha app, all you have to do is plug in the value of x. Lambert W function is written as product log. W is replaced by the product log, and enter the rest as usual what appears on the value of x, like in here, negative 1/2, negative 1/4. W is replaced by the product log, and solving for the w sub negative 1, you'll have to enter negative 1/2, w is product log, and then enter negative 1, and then the value of that inside the parentheses, negative 1/4. So you will find this value. All right, and so that's all for now, and thank you for watching. I hope to see you in my next videos. Have a great day, everyone. For those new to my channel, I would appreciate if you can hit the like button and subscribe for more videos of this kind, or make a comment, or let me see what side of the globe you are watching from. Thank you very much, everyone. Have a great day. Bye bye. Take care.